Hello dear students, in this video we will learn how to form a differential equation from a problem. Differential equation from a problem. So friends, in first video we have seen what is a differential equation. What is a differential equation? We studied about the solution of a differential equation. We studied that there are two types of solution of a differential equation, that is general solution and particular solution. Okay, and we also know that the solution for differential equation is a function. So these things we know about differential equation. Now, in today's topic, we will learn how to form differential equations from a given problem. Okay. So first thing, the key concept over here to form a differential equation from a problem is you should be able to successfully interpret the language in the question. Okay, so this is the most important thing. The correct interpretation of the language in the question will help us get the correct differential equation. For example, let's take the rate of increase of the number of people in a city is k times the number of people in the city. So what is this statement? It says the rate of increase of the number of people in a city is k times the number of people in the city. Okay, next statement is the number of people present in the city at time t is x. Now we have to replace the word the number of people in the city by x, right? So the number of people present in the city, if I replace it by x, so number of people present in the city, if I replace it by x, then the rate of increase of x, then we can say, therefore, the rate of increase of x is k times x, isn't it? Let's see again. The rate of increase of the number of people in a city is k times the number of people in the city. Okay, if the number of people in the city is x, therefore the rate of increase of x is k times x. Now this rate of increase of x with respect to time, this rate of increase of x with respect to time t and is much easier to translate into a differential equation, isn't it? Differential equation, that is dx by dt. This is known as rate of change of x with respect to t is equals to k times x. Okay, where k k is nothing but greater than 0, because the rate is increasing. K can never be negative. Okay, so this thing is important. The proportionality constant k is always greater than 0, because here we're talking about the rate of increase of x. Okay, so that is how we form a differential equation from a given problem. Now friends, let's see one question based on this. Let's see a question. The question says velocity is defined to be change of displacement with respect to time. So what is the first statement? Velocity is defined as the rate of change of displacement. So rate of change of displacement with respect to time. Now it says the velocity of a particle at time t seconds. Okay, at time t seconds is inversely proportional to its displacement s from an origin O. Okay, so this is the statement given to us. Now the sub question which they have asked: form a differential equation to represent this data. Okay, let's read this question once more. It says velocity is rate of change of displacement with respect to time. The velocity of a particle at time t seconds is inversely proportional to its displacement s from an origin O. Right, so this is given to us. So we can say the solution v is equals to ds by dt. That is what the first statement says. Velocity is rate of change of displacement with respect to time. Let's say if displacement is s, then ds by dt is velocity. And then the second statement says the velocity of a particle at time t seconds is inversely proportional to its displacement. Therefore, we can write the velocity, that is ds by dt, is inversely proportional to its displacement, that is 1 by s. Now, this is same as writing equals to k by s, where k is nothing but the proportionality constant. If you remove the sign of proportionality, you'll get a proportionality constant, which is k. Okay, so now this is the differential equation. Okay, ds by dt is equals to k by s. Now, to find the value of k, certain conditions will be given to us in the question. For example, let's say we are given that these are the initial conditions. The particle has a displacement of 2 meters. What is given to us? The initial condition means at t equals to 0. The displacement of the particle is 2 meters from the origin O. Okay. After 1 second, the particle has a displacement of 5 meters. All right. So now we have to find the relation between S and T. So let us call this as equation 1. So from equation 1, I can say ds by dt is equals to k by s. Now to solve a differential equation, we know that the method is variable separable, which implies s will go to left hand side, k will be on right hand side, and we can take dt and then integrating both the sides. So we'll get s square by 2 equals to kt plus c. Okay, so this is the differential equation which is in the form of general solution. All right, now we have to find the value of c. Okay, so to find the value of c, certain conditions are given. That is initial condition when t is equals to 0. So plug in t equals to 0 plus c. S is how much? 2 meters. So 2 square divided by 2. So k into 0 is 0 plus c. 2 square divided by 2 is 2. Therefore, we got the value of c as 2. Now put this value of c back in this equation. We get s square by 2 is equals to kt plus 2. So now this is a particular solution. Okay. Now we can find the value of k from this second condition after t equals to 1 second. So if I plug in t equals to 1 second, I'll get k into 1 plus 2. Displacement is 5 meters. So 5 square divided by 2. So therefore, k is equals to 25 by 2 minus 2, which is 21 by 2. So we got the value of k as 21 by 2. Replacing the value of k in this equation, we get s square by 2 equals to 21 by 2 into t plus 2. Okay, so now this is the final equation in terms of s and t only. So we got a function that is displacement as a function of time. Okay, so now anything can be given to us. If we are given with displacement, I can find, if this is given, I can find time. If time is given, I can find displacement. So I hope basic idea of differential equation from a problem is clear to you. Thanks for watching.